Okay, so I don't know if any of you people here are Megan Trainor fans. She's a fairly new artist, but she has a song, I'm All About That Bass. And I'm representing Ubiquity Robots. We're all about the bass, the robot bass. And the question in our elevator speech that we're giving everyone at Makers Fair is there are hundreds of thousands of cell phone apps, but there'd be no cell phone apps if every cell phone app developer had to build a cell phone first. That's what robot developers are facing, right? They have to start from scratch. So Beam, Suitable, Fetch, Fellow, Savioke, they all had to build their own base. And what does a base have? It has wheels, has a chassis, has a controller. They all have to start from scratch. So they design their prototype, and then once they get that prototype working, then they have to manufacture it. And normally, they haven't thought about the supply chain at all when they go to manufacture, so it ends up being very expensive. Same thing happened when we did the first personal computers, right? They were difficult to manufacture designs. Apple IIe was what, around $2,000? And it was expensive to manufacture.
IIe was an improvement over 2.
Yeah. I mean, basically it was, it was put together by two guys in a garage, and that's what it looked like. So we've always been designing around what is available in the supply chain. So we can build this platform here for, so perfectly quiet. I'm just doing ROS teleop. I'm just holding down the U key. I'm doing this Wi-Fi. This is a base that costs us under $500 to make. Dead quiet, can move 200 pounds. So and it's designed for you to put what goes on top in your application. So what we wanted to do when we started out around 3 years ago, I guess Steve was there when we had the wheelchair, right? Right, and then we started with Roombas and trying to get Roombas to drive around cones. But what we have now is a machine that is easy to manufacture, can do it low cost, and hopefully we're going to kickstart this in a month. Well, probably around August now, and hopefully sell a lot of them to you guys who want to, as long as you're not walking your robot, need to move something around. And we're not selling the application, that's for you to figure out. Whether it's handicapped or elder assistance, whether it's a cart, whether it's a waiter, whether it's a telerobot. We're using ROS, so most of the code is off the, most of the code that I deal with, someone else has written. I do not have to write the code from scratch. So we also have Wayne's in on this too. He's in on the conspiracy. We also have taken the club bot and made it into a miniature version of this that's code compatible. 2 wheels, odometry on the wheels, upward looking camera for odometry, and hopefully we will be a real company someday and actually sell product.
We'll see.
Yeah, thank you very much. Oh yeah, I can answer. Sure, absolutely.
What is the torque on your big motor there?
I don't know what the torque is. I forget what total wattage they can dissipate. They're designed for scooters.
Okay.
So they're designed to run up to like 10 miles per hour. So we're running them at maybe 10% of rated speed. So they're brushless hub motors, so they're very efficient. That brushless hub motors are what makes drones possible. I mean, until we got those good magnets, and the benefit of it is the motor is inside the wheel, so you don't have a gearbox, you don't have an axle, you don't take up a lot of room. So basically, the chassis is sheet aluminum, bended frame, pop riveted together. If something breaks, it's easy to fix. And we looked at different things. We looked at welding the chassis and decided that wasn't going to be feasible because people welding thin aluminum, they don't set up the jigs right and it's crooked. So we're using, everything is off pretty much off the shelf, easily available. Sealed lead acid batteries that we're not selling, that you buy separately. You have 3 options of batteries, 5 amp hour, 10 amp hour, 36 amp hour. There's a lot of room. So if you want to do a warehouse app, yeah, you can move freight around a warehouse, all day and then charge it at night, or just have different robots charging and
So
take
your
them over.
motor controllers are also off the shelf?
The controllers, no. The motor controller is a custom component.
Okay.
That's where all the brain sweat is involved,
Okay.
right? Because you have and we've designed it with the developer in mind. So there are plenty of USB charging ports. We have dual 12 volt and 5 volt supplies plus 24 volts going to the motors.
So you're doing trapezoidal drive on the three-phase,
Differential.
different?
It's 2-wheel drive.
No, on the commutation of the motor.
I'm not sure I understand your question.
I don't
It-
think so.
It's
It's not
three
just
three wires.
3 wires.
3 wires, so you're either making them positive or negative depending at different speeds to control the rotation of the motor. And you have 3 Hall effect sensors inside, which is a benefit because the sensors are inside. It's also a bit of a issue because you're only getting 115 ticks per wheel.
Right.
So you don't have super accurate odometry. But we're working on a software solution for that.
But the PID loop and all that is done on an embedded microprocessor on that board, so you don't have to worry about it.
No, I was just, I was also considering commutating brushless DC motor, and I started experimenting with the AMS magnetic absolute encoder, and it's better, much better than all effect.
Yeah. Also, we're running, right, it's open source software. It's ROS running on Ubuntu. And open source software needs open source hardware, right? So the software development costs are going to be way down, right? If you start from scratch, you have to not only do the mechanical stuff, also do the software you'll never get your project off the ground. So that's my
To answer
story.
your question, is I think 250 watts per wheel, but I'm not positive.
Yeah,
And
it probably,
so what volt?
it's 24
24
volts. Yeah, you probably could run this at a lot higher speeds, but it's not recommended. It's indoor environment. We actually did some film of me driving and Tony Pratnakis riding on it, and Tony hasn't spoken to me since. So we also did it on a busy street and outside, so he was wearing a helmet, but he hasn't. I don't think he's talked to me since, honestly.
That's 24 volts.
Okay, thank you very much.
Another question?
Oh, sure.
Of the original Hercules challenges, which ones do you still have to meet?
We haven't drawn a chessboard on the floor, though I can make a square fairly accurately with Loki. I imagine I could do a chessboard pretty easily if I just want to take the time. It's just a Python script, and I already have Patrick Goebel's Ross by Examples. Ross by Example. Yeah, Patrick never comes anymore.
Patrick's here.
Oh, you're here?
Ladies and gentlemen.
Okay. So on this guy, on the little guy, I'll do that after. I'll run I can run your calibration routines. Can't run calibration on this because we're not reporting odometry, we're just doing command velocity. Yeah, hopefully Patrick is going to, if we can talk him into it, write a ubiquity version of Ross by Example, and then we'll have our documentation taken care of too.
Did you get the autonomous pizza delivery then?
We did a cookie delivery a long time ago. The original thing was development challenges, and the last challenge, I don't know. I think we actually can start to actually build up our platform and do that. The last challenge was to survive for a week, going to a charging station to recharge, doing face recognition of a particular person.
Yeah, that's what it
That was the 12th challenge. Haven't done that yet. But I think we've done like a good 6 of the original 12. Yeah.
Also, Alan, in the analogy you like to use so much regarding bringing a can of beer from the fridge.
That's
what
right.
should this actually be bringing to
This
you?
should bring you the keg,
Yeah.
right? This should bring you the whole keg. Or actually, it may be able to bring you the whole refrigerator. We haven't figured out how to unplug the
Any
refrigerator
of the
yet.
challenges of Hercules, 12 challenges, the tasks of Hercules are applicable to the home group, to the HPRC challenge next month.
Yeah, any of
Oh,
them.
that's really out.
So drawing a square would be, I don't know, a chessboard might take too long, so maybe drawing a tic-tac-toe board would be sort of a step towards there. You draw, and then playing tic-tac-toe, okay?
And then last question, how soon and for how much can I get one?
Base configuration, we're looking for the big one
I'll
for
do
around
it.
$1,000.
Yeah, it's got 12 tasks.
And soon?
Hopefully August.
Oh, okay.
Hopefully August, we'll try to do a Kickstarter. I don't know how many we can sell. It depends. I mean, David's going to China next month and spending a month there talking to manufacturers.
Any HBRC member privileges to get one early?
Well, we are actually looking for some alpha customers. You know, people who have an application ready to go, that'll work with us. We're already working with Dillo. And then another fellow we're working with. Thank you. I've taken too much time.
Okay. So who's next?
So this is the animatronic I have made, well, animatronic head, but I have made for my Creature Lab class at Rocket Science. Basically, it uses servos to control the movement of the eyes, which move, and jaw. It moves a bit. The eyes also light up a bit, so it uses servos, as I've said, to control it. There's an Arduino board, and it just runs off any USB power source. Here's a cosmetic, and yeah.
Give me a, hey, Kip. Give me a-
So what's the name?
Well, this is the Freddy animatronic from, kind of based a little off the Five Nights at Freddy's series, but my own interpretation of it.
Looks a little like Tesla. That's his dog.
So yeah.
Did he move? Did you do the demo? Is that the demo? All right, very good.
Very good.
Yeah, well, we'll unfold her and then we'll stand her up. We'll unfold her slowly, because we don't look back for a moment too fast.
It's alive.
Well, true, when you backdrive the motors, they create voltage in the system and actually start to turn things on. I'm going to backdrive them very slowly so as not to damage the gearbox. I have a new gearbox on order. It's more backdrivable. I think we can stand her up. No, on the table.
Yeah.
Maybe.
Not creepy
We'll
at all.
see. So, yeah, not creepy at all. So I guess what I'll do is just make sure she doesn't fall. As you can see, Venus de Milo here has no arms. We're working on new sets of arms. I've had this guy in here since I've been a member for about 5 years, and there's virtually no parts on here that are the same. So it gets rebuilt pretty much every 6 months. And this version has all new leg supports, which are much stronger and will allow me to get tighter tolerances in the slop mechanical slop that's in the system. Additionally, this model has my own servo designs, which are on the hips here, which if you can look closely later, are just plain gear motors, DC gear motors, with a magnetic encoder, 14-bit resolution, and a dual motor controller that I built myself from a PIC. Runs all the PID stuff and the PIV, and pretty much is going to get shrunk down into one board, which will then get encapsulated in a module like this. And it will have much better resolution than these, which use potentiometers for their feedback.
Can you say what that is, the red box? The red
This is just an off-the-shelf servo. So this is they call it 1,600 ounce inches, but it's really more than that. That's just what they call it.
The 3200s.
Oh, the 3200s.
Yeah.
3200s, yeah. This particular one is in foot-pounds. It's 250 foot-pounds. And so it really does have the torque and the stability I need, whereas smaller servos of my initial design failed miserably and broke all the time. These guys break less often, but they do break. So I've got the gear manufacturer that made the gearbox inside here, made these, and is making me replacements for in here that will backdrive better and have tighter tolerances. I'm going to take the Pololu board that's inside here out and put the one of my own design in, get rid of the potentiometer, and get rid of the fact that I'm driving these using RC positioning, and instead we're going to run a 485 bus through there and pretty much run it at about 4 megabits, and just we'll have a custom protocol to send the data up and down the stream. The 14-bit resolution on the magnetic encoder is stable at 11 bits. The bottom 3 bits twiddle a bit, but 11 bits is very good. It's 2,000 bits per circle, so that's pretty good for a full circle. And it's better than anything that I've ever seen with a resistive encoder. And so that's what I've been working on. So, any questions? Whatever.
You've got some kind of face tracking software or something.
Yeah. Let me explain the creepiness. I see that the head's not in the camera. Oh, I didn't want to show that, but okay. So last year at Maker Faire, there was no head at all, and nobody looked at my robot on Saturday.
They thought it was a ladder.
They thought it was a ladder, really. On Sunday, I put a balloon with a smiley face on it on top, and everybody was pointing. Look at that, look at that. So this year I went for the creepy effect. Chris and I worked on making this guy, there's 2 servos in there, and a tracking system, and we made it just follow everything, and people just loved it. Kids loved it. They're going like this, trying to fool it, and it was just great. So we got a lot of mileage out of the creepy head. I got creepiness from seeing all the bots that Camp does. He's got some of the creepiest bots around.
Thank you very much for that.
And so I learned from him. So yes, so that's why we have the creepy head. And so hopefully by next month we'll have arms as well.
How many degrees are the servos, the red ones?
So they will go approximately 200 degrees before the potentiometer snaps. Okay. And when that snaps, then the gearbox goes crazy, interferes with something else, and busts the gear. So you can see why it's very frustrating. Additionally, if I put them both at 1500, which is the center, and they're standing up, and then I command one to 1600 and the other to 1600, for example, in the legs, they're off by 10 degrees at least. So it's not very good for doing a walking animation because it doesn't really follow, whereas the magnetic encoder is so accurate. And you can spin it 360 degrees and it doesn't care because there's nothing making contact. So the reason I thought that might work with the Club Bot is because it would work as a commutating encoder as well as an odometer with 11 bits of resolution. And they're cheap. The chip is $4 or $5 for an encoder. So anyway, more on it next month.
You still have force sensors on the...
Oh yes, and so I still have the force sensors, and they work very, very well. There's a processor board here, PIC-based, and then this board on top of it reads the 8 different force sensors, and it accumulates the data, creates a center of mass, and then adjusts these 2 servos right now.
Do you have a plan for walking? Are you going to be leaning sideways?
Yes, so there's currently an animation, and we were running it at Maker Faire. I broke the encoder on this one, so we couldn't really run the full animation. I just got the part in today from AMS to repair that. I let the magic smoke out by letting a wire hit down. Yes, everybody does that at some point in their life. And so the animation right now is what we call a march, which is our first step. And a march is a lean and lift the opposite leg. And then put it back down, lean to the other side, and lift the opposite leg. And so just being able to accomplish that is it's a small step for Watson kind, or mankind.
Are you familiar with Link's motion?
But yes, I've built a bunch of robots from their parts.
For example, that's an example of a simple walker.
Yeah.
Sideways.
So what we want to accomplish with this walker is not just a static walk, but because we have the force sensors and we know where the center of mass is relative to the foot, we want to create a dynamic walk where we actually put the mass outside that in a specific vector and then drop the other foot to catch us along that vector.
You also just flip the foot, fall forward, and catch.
That's right, and the other foot catches. And that's the dynamic walk that we're introducing.
I remember those servers were kind of slow for that type of thing.
These, yeah, they're just not great service. We were trying to get into the DARPA challenge, and this was the best thing we could find on the market without buying harmonic drives for $1,000 each. Anybody can build a $500,000 walking robot. There were a whole bunch of them there, and no one's going to go to market with a $500,000 robot. This bill of materials will be somewhere around $10,000 to $15,000.
When you're testing a walk animation, how do you just let the robot fall if it falls, or do you?
So we tether the robot for now, and what we're trying to do is to get a ROS interface where we can actually see what the center of mass is doing. That's very critical for us, so we want to have a little ball in the center of a square of each foot showing where that is. And I've got a person who is at Robo Games in Texas who's been doing a great deal of ROS work, and she said she would take on that part of the project. Unless somebody else wants to take on that part of the project. We're always looking for volunteers. So, yeah. Chris?
I just wanted to, because there was questions about the animation. The goal, and I think in past meetings I've shown some of my YouTube videos, most of the animation data that this robot's going to use is self-learned from the robot itself. It starts off not really knowing much, and it has a self-image in a simulator. We're using VRAP. And I think we also had a version in Gazebo. It learns how to do an animation based on a goal that we find mathematically. For example, walk is make your x vector get larger and make sure your z vector doesn't drop. So in other words, don't fall over, but move forward. And it starts off kind of like an epileptic baby, but after a few iterations, it will start to stagger forward. And it basically learns by itself, reinforcement learning and neural networks. So the plan is, don't have pre-canned animations, have the robot learn what it needs to do, hopefully in real time.
That's good. Very good. Yeah. Thank you.
All right, so this is what I was showing at the Maker Faire, and what I have here is a $20 stereo webcam. It's the Minoru stereo cam that I got from Amazon. And then there's the V4L2 stereo program, which was originally optimized to use SSE instructions for Intel processors, and I converted it back to regular C, and I'm running it on a Raspberry Pi 3. And then if you look at the colors, you can see people in the front row here or nearby are a little bit more pinkish than the background, which is dark blue. But if somebody holds out a hand or something in front of the robot, then you can see now it's orange or
too close. Too close.
Too close.
yeah, and it gets brighter, uses color to indicate the depth.
Fascinating. Very
How many
good.
frames per second would you say that's?
So it's fairly slow, yes,
What software-
because it's only single threaded. It's only, it's not trying to use the GPU or anything like that yet.
I only asked to tie into the next question.
Yes. Our friend from here will. So there's that, and then
So what software are you using for that?
this is the V4L2 stereo program. If you look for it, it's a Git tree, so it's all open source.
Okay, you post that on the list?
Yeah, I can post that.
Cool.
That's true.
Maybe I'll get a picture.
Oh, okay.
Yeah, there we go. Act like you're having a good time.
And of course, there's a robot motion editor program that lets you set each joint angle and, play it as a keyframe kind of movie. And I was demonstrating that at the fair as well, just to go through a couple of simple motions.
The camera's separate from the robot, right?
Yeah,
Those are
it's
two
a
separate kits that are.
no, it's one. So it's a stereo webcam. You buy it as a stereo webcam. It has one USB plug that plugs into the Raspberry Pi 3.
No, I'm saying you said that the robot, the humanoid robot, you can do animations with that. That's what you're going to demo next.
Oh yeah, it can stand up and wave and stuff.
What's that thing called?
That's the program. Oh, this is the HROS1 kit from Trosson Robotics.
Oh, for Trosson.
So it's based on the Darwin OP design from Robotis, which makes the Dynamixel motors.
Yeah. But you said it's run by Raspberry Pi inside.
Yeah, there's a Raspberry Pi, and then there's also a Trosson motor controller, which they call Robotics Pro, which is really similar to the Robotis, I think CM730. There's an accelerometer and gyroscope on the controller board for balance.
Does the Robotics Pro have Dynamixel support for readback and all that, or is that?
Yeah. So each motor has its own microprocessor, position encoder, does torque limit, temperature, checking, and will shut down if there's too much load or too much heat. And you just send it little messages over a TTL serial bus to set the goal position and that sort of thing. Yes. Helps if you So I was just running this in a little loop.
The latest one magnetic encoder and STM processor.
All right.
Magnetic encoder.
Okay. I met Samesh and Sharang. They were actually right next to our HBRC booth. They've come all the way from India. And Sarang here, little Sarang made a smart seatbelt display. You want to tell them about it? You got a microphone there for him? Show them the picture.
Oh, yeah. Shows that.
Sarang?
Yeah.
So you can explain. Explain it real quickly. Smart seatbelt.
Yeah, actually it's a smart seatbelt. Smart seatbelt and husband is mother and my father was talking together that the children want to put the seatbelt in the school bus, and my mom told him that mom actually told the school that you want to put the seatbelt, but school told that to my mom that when the children put the seatbelt, they cannot know how to plug it out and release it. Hearing that, I made this smart seatbelt. Yeah, certainly a smart seatbelt. It can, when the accident happens, it can, when the bus can fall to a water or river, and the bus can.
You built it with the Arduino, didn't you, Samesh? Okay, and it basically sends tactile, water, and an accelerometer, so if the bus turned over, the seatbelt would sense it and latch, right?
Yeah, that's good.
Okay. Okay. We're kind of out of time here. I just want to go through these Maker Faire images quickly. This is our own. Thank you. Oh, stay up here because you guys are in these pictures too. So here's our own Dillo with Annika. Kathy Whitesell makes doll clothes. And so here's the eagle with us. And there's our own Kit and me. Hey, Kit was there. And Rocky. And there's Sarang and Carlini and myself. And there's Sarang again. Now this is him showing his smart seatbelt at the Maker Faire. There's Balaji and Sarang. This is Nick Donaldson, king of the hexapods, also made the Funky Monkey. This is Marauder. It's a 6-foot-long hexapod that rollerblades. This is kind of like a Chitty Chitty Bang Bang ride that was pretty cool. Daleks, steampunk robots, a lot of steampunk at Maker Faire. This is, you might recognize Romibo from Origami Robotics. Jared was there with his robot for special needs children. Here's where Watson seems to fall down, kind of creepy. Bicycle. And I've posted this on our mailing list. Okay. She had just come from the dentist and had a kind of a crooked smile there. But anyway, so let's go through quickly. This is Steve Nelson's talking robots. They're like Beavis and Butthead. And you probably recognize the Ubiquity robot there. There's Gopi. Yay! Watson, Bill Sherman, and his line following robot. This won't last much longer. There's Ralph Campbell, a real trooper at the booth, ladies and gentlemen, with Ralph 2.0. There we are. That's Copperbot there, kind of a steampunk robot. It had a lot of pretty lights on it. Cheshire. Oh, this is one of I thought was the most interesting. This is a 3D printed open source robot. You've probably heard of InMove. There was only one of them there last year. This year there were 4 of them. It's just an open source 3D printed robot. That's a cute couple from New York there. They make robots with different motions. Here's the Zybot and the Xeno. And there's Ralph and Mark talking shop. There's some kids having some fun there. There's Danny, our own Danny with the challenge bot. Yeah, he had his own booth there. And not creepy at all. There we go. There's the Fiddler bot there, one of everybody's favorite. This is another one of the InMove robots. Some kids from Guatemala printed that one out and brought it out. There's John Sokol here. John and John. And we're almost at the end. Dun, dun, dun. Oh, Ralph 2.0 with Ralph 1.0. Nick Donaldson, king of the hexapods. Oh, this is a 3D printer. This is a giant 3D printer. You see those statues there? They printed those out. This is a transformer. It actually transforms into a little car. It drives around. Okay, and that's it, folks. Thank you very much. HBRC Challenge next month.
Next month. And then
14th annual.
is posted on the mailing list the link to those pictures you just saw.
Yes, yes, yes. No extra charge.